So make sure you're open to page 460, and we're going to look at the dropped object item on number 21. You can use the expression, the square root of h over 16, to find the time in seconds that it takes an object dropped from a particular height of h, whatever it is, to the ground. Okay? By the way, let's simplify this really quick. It would be the square root of h over 4, right? Because this has a square, perfect square. Okay? So rather than using this, I'm going to use this nice simplified one. Now, you take an object and drop it from a height, which is h of 63. So instead of having h, what am I going to replace the h with? Because they give us the height. 63. Bravo. Notice how I cheated here. I just went ahead and factored it. Okay? If you do that, it's fine, just as long as you know what you're doing. The height goes here. Height is 63. I factored it to 9 times 7, rather than writing square root of 63 over 4. Okay? You with me? Good. So here we go. Is 9 a perfect square? Obviously. 3 radical 7 over 4 is the amount of time in seconds. What on earth does that mean? It says, approximate the time to the nearest second. Okay. So I'm going to go 3 times the square root of 7, which gives me that number. And I'm going to divide it by 4, which gives me a real world number, 1.98, which is approximately 2 seconds. Okay? 2 seconds. All right? Now you're thinking to yourself, well, what if the object is heavier or not? Well, when you get into physics, go ahead.
Objects of different weight fall the same speed.
Bingo. It doesn't matter. You'll find out that the amount of space the object takes up, like say a feather, would go down more slowly because the feather's wind resistance, but that's a whole nother class. Okay? So again, it says you can use this expression to determine the time in seconds it takes an object dropped from a certain height. So whatever the height is gets plugged in here. They tell us that, oh, and then I simplified it, because rather than dividing the square root by 16, if I simplify it and divide it by 4, it's easier. Okay? Here's the expression. It says write the expression in simplest form. That's this. I reduced it. Then approximate your answer. There's the square root of 63, which is 9 times 7. Square root of 9 is 3. 3 times the square root of 7 divided by 4 is 1.98. So it's approximately 2 seconds. Okay? 23. Here's where these get a little bit more ornery. Simplify. That does not mean give me a decimal answer. 75x squared y. Okay. 75x squared y. Factors of 75 that include a perfect square? Anybody know? Factors of 75. 1 and 75? No? 25 and 3. She's right. 25 times 3. Okay? She's right. Any number that has an even exponent is a perfect square. So I'm going to leave that just the way it is. And y cannot be factored. Okay? So the items that are not perfect squares are the 3 and the y. The square root of 25 is? Bravo. Comes out of the radical. The square root of 3, can't do it. The square root of x squared. X is right. Square root of y, can't do it. There is your simplest form. The way you know it's simplified is if there is no more perfect square factors under here. 1 and 3, not a perfect square. Y to the first, not a perfect square. This is number 23. Number 24, number 24 is similar, only it's a fraction. So I want to do one really similar to number 24. Okay, so I'm going to do this. It's not actually 24, but it's similar. Okay, here we go. This one's a little bigger. Okay. The square root of 400k over the square root of 625c squared. Okay. Is 400 a perfect square, or does it have its perfect square? Square root of 400 is 20. Okay, comes out of the radical. Is k a perfect square?
No.
Stays underneath the radical. Okay? Perfect square factors of 625, or is it a perfect square?
Perfect square.
25 times? It is a perfect square. Okay, I'm sorry, I didn't hear you right. 25. So the square root is 25, and the square root of c squared is c. You might think you're done. Reduce the numbers that are not under a radical. If both numbers were under a radical, they could both be reduced together. But you have to reduce numbers that are in the same position. These are numbers outside of the radical, so they would reduce one another. By 5? So we should end up with 4 radical k over 5c. Okay? They're both reducible by 5. Now you might say, well, what did you mean, Mrs. Myers? Only can reduce because they're in the same spot. Well, here's another example for you. I'm just changing it a little bit. Look at this for a minute. Notice this. The 15 and the 25 you would think are reducible by 5, but they're not. This is radical 15, okay, aka root of 15, which is like 3 point something, 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 right? This 25 is whole number 25, okay? So you cannot reduce this with this in this location because this is not actually 15, it's the square root of 15. So here you can reduce. Here, you cannot, because they are not under the same rule. If it was radical 15k over radical, well, I don't want to do that. Let's do, hold on, I'm trying to come up with one. 30. Yes, that's a good one, 30. 6 and 5. If it's this, 6 and 5, this doesn't have any perfect square root. 1 and 30, 2 and 15, 3 and 10, 4, 5, and 6. Okay, so neither of these has perfect factors, but this is the square root, this is a square root. They will reduce each other. Okay? Yes, reduce. Okay, so the rule is, if they are in the same location, either outside of the radical, both of them, or inside the radical. You don't have anything like this, but I just thought in case you're asking yourself that question. Okay, that's number 24, or a fair representation of number 24. 25. Here's a big ugly one. 7200 m squared n squared. All right. How about 3600 times 2? Yep, that'll work. So remember the square root of 36 is 6. So the square root of 3600 is going to be 60. Radical 2 stays underneath. There is no perfect square. Square root of something squared is that item. Ran out of room. Okay, so it's 60 mn radical 2. Found the biggest perfect square factor, pulled out the perfect square, and whatever did not have a perfect square, it stayed underneath. That's why the 2 is still underneath. Okay? Square root of any item squared is that item. So, square root of m squared is m. Square root of b squared is b. See what I'm saying? So if it's a square, you just pull that item out because bb is b squared. Tricky, I know. Okay. We're going to skip 27 because you're not doing that today anyway. Okay? I don't want to take up more of your time.